morning, guys. There's these 3 assignments I asked you to turn into Google Classroom a couple of classes ago, but if you did not do that, this is your last chance for full points. So if you could please find those and get your phones and smartwatches put up during the minute of silence, so then we can get started. And I'm not sure why, but our bells are turned off this morning, so we need to move that direction now. This is a no calculator quiz. I believe this one totals up to 20 points, so you want to do the best you can. Okay, also, every question is worth more than 1 point, so you get partial credit on everything, so make sure you're shoving as much of your thought process as you can. And once all the quizzes are in, we'll look at the handouts y'all picked up. It's pretty short. Still need to get it knocked out today.
Your child needs is 3.
Okay, I think we've got all the quizzes in, so let's look at this short little handout that you guys picked up on the way in. So there's really one more topic we've got to do for this unit, and it just has a ton of different stuff to it, but it's all kind of trying to achieve the same thing. Sorry, my internet's slow, so I'm still trying to get it loaded over here. But the last thing that we have for this unit, and again, this is our last unit, so last thing for this unit, next test and semester test all combined, is graphing rational functions. So a rational function basically means a function that's one big fraction. And for us to be able to graph those by hand from scratch, we've got to be able to find some of its characteristics so that we can eventually throw that onto a graph. Now, there's a bunch of stuff to this that we won't look at today, like horizontal asymptotes and slant asymptotes and adding points to the graph, and I'm sure I'm forgetting a couple there. But to kind of break this up into parts, because otherwise it's like 9 or 10 things being thrown at you in one day, I've got 3 of the parts that we will work with, and that's what this handout is. So this handout, we're going to worry just about holes versus x-intercepts versus vertical asymptotes, because really the work behind these 3 is almost the same thing. And then next class, when we have to do the rest, you should at least feel comfortable with this part already. So holes are going to occur. That's where you have just an instantaneous break in the graph, just one little instant that doesn't exist. This is going to occur when you try to do 0 divided by 0. So in other words, the x value that makes the numerator and denominator equal to 0. If it makes both, and I'm going to actually go back and squeeze this word in, both the numerator and denominator equal to 0, that will be the x value of the whole. And then to find the y value of the whole, we'll have to do a little bit more, but we'll come back to that once we see that. So, wholes are going to occur when you have 0 over 0. Any x value that makes the numerator and denominator 0 at the same time. Okay, x-intercepts are technically when y equals 0. That's consistent all through algebra. But for your big fraction, because again, these are all rational functions, which basically means fraction, the time a big fraction is going to equal 0 is when you get x values that make only the numerator equal to 0. Because if the numerator is 0, bless you, if the numerator is 0, 0 divided by any other number besides 0 is 0. And then if your whole fraction equals 0, that means y equals 0. And if y equals 0, we know it's an x-intercept. So this time I'm going to highlight the word only. Because if there's a number that makes just the numerator 0, it's an x-intercept. But if it makes both the numerator and denominator 0, it's a whole. It can't be doing both things at one time. So it's either a whole or an x-intercept. It can't be both. And that one word of the definitions kind of change that. Okay, vertical asymptotes are going to occur when you take a number other than 0 and try to divide it by 0, because we can't divide by 0. And this is going to create vertical spikes in our graph, known as vertical asymptotes. And so to know what numbers make you divide by 0, this is going to come from any x value that makes only the denominator equal to 0. The reason why I have to squeeze the word only in again is because if it makes both the numerator and denominator 0, it can't be a vertical asymptote because it's a whole instead. Visually, each of these things look like different stuff. So I think it's going to make sense if we jot a couple, just like a little quick picture of what we're talking about here. So if you have a function, if it has a whole, that just means it doesn't exist at one instance. An x-intercept is anywhere y is 0 on the x-axis. And then vertical asymptotes are when you get these vertical spikes in the graph, like this. This is a vertical asymptote. So the reason why I grouped these three together, and I think it makes sense to learn these all at the same time, is for all three of these, you need to know what numbers make the numerator 0 and the denominator 0. So that's going to be one of our challenges here. So let's look at a couple of these together, and then I'll tell you how you can check the rest, and then you can practice with the rest. Okay, so before I can even begin to tell you if this has any holes, x-intercepts, or vertical asymptotes, I need to know what numbers make the numerator 0 and what numbers make the denominator 0. The quickest way to do that is going to be from factoring, but I guess you could do quadratic formula. It's just going to take you a lot longer. And then from factoring, I can see the numerator equals 0 at 4 and negative 1. The denominator equals 0 at 4 and negative 2. So if there's any numbers that make just the numerator 0, like negative 1, it would be an x-intercept. If there's any numbers that make just the denominator 0, like negative 2, it's a vertical asymptote. Vertical asymptotes are vertical lines, so make a habit out of saying x equals. And if there's any number that makes both the numerator and the denominator 0, that will be the x value of the whole. You also need to find the y value of the whole, though. So let's go back and add this to our notes up at the top. So the x value that makes the numerator and denominator equal to 0 is the x value of the whole. You're going to plug that in to the reduced fraction and solve for y. Of course, you can reword that if you'd like to, but we're going to plug in the x value of the whole into the reduced fraction and solve for y. So what I mean by that is, if 4 is making the numerator and the denominator equal to 0, that means that the numerator and denominator should have factors of x minus 4. So let these two cancel out and reduce, and then we're going to plug this in to the reduced fraction, to the leftover stuff. And we're going to be left with 4 plus 1 over 4 plus 2, so 5/6. There's going to be a moment where this graph doesn't exist when x equals 4 and y equals 5/6. Now, I'm going to go through another one with you just to kind of summarize what you should be looking for. But after that, I'd like you to check with graphing. So give me a second here and I will graph. I'll graph this function and then we'll see that all that information looks correct. Sorry, it's just being slow today. Give me just a second. Well, that one's just struggling, but I'll come back to it. So let's go ahead and work 5, and then we can go back and check 4 and or 5. Okay, so really all it amounts to is the stuff that you have to memorize is that if you have a number that makes just the numerator 0, that's an x-intercept. If it makes just the denominator 0, vertical asymptote. But if it makes both 0, it's a whole. It can only be one of these things at a time. These 3 things look completely different. Your graph can't be doing 2 things at the same x value. So you've got to figure out what numbers make the numerator and denominator 0. So factor the numerator, maybe start off with the GCF, and then if it factors more, factor it more. Factor the denominator, all that it has is an GCF. But then once you have the factors, you should be able to quickly see there's 3 numbers that make the numerator 0, 0, -2, and -1, and 2 numbers that make the denominator 0, 0 and -5. Okay, and then you're pretty much ready to write out your answer. Obviously, you're going to be feeling a little more confident and do that quicker the more of these that you do. But any number that makes just the denominator 0, like -5, would be a vertical asymptote. It's a vertical line, so make it x equals. Any number that makes just the numerator equal to 0 is an x-intercept. There's 2 of those this time. And then if there's any number that makes both 0, it's instead going to be a whole. So for a whole, the x value is the x value that makes the numerator and denominator 0. But the y value, this is the part that sometimes students forget, so you need to emphasize this or put it in words or something. But the y value comes from plugging in the x value into the reduced fraction. The fact that 0 is making the numerator and denominator 0 means that there's a common factor that you could cancel out and reduce, and then you can plug 0 into what's left over. So you'd be left with 2 times 1 over 5, so there's a whole at 2/5. When x is 0, y equals 2/5 is a one instance, one single point that the graph is missing. So really the bulk of the work is just trying to memorize those 3 definitions and of course factoring. So let me try this graphing again. Okay, this is looking better. Okay, let me zoom on this a little bit so I can see it better. Okay, so I'm going to go back and graph this equation in number 3 or 4 to check our work. So it is perfectly fine to use a calculator to check your work here, but don't just graph it and try to get the answers from your graph. Partly because your calculator is only going to be able to do so much of this for you anyway. Okay, so to check the answers to number 4, we said that there was one x-intercept of -1. So it better touch the x-axis only one time, and it better be at -1. That looks to be correct. Also in question 4, we said there was one vertical asymptote. So you need to know what those look like. Those are the vertical spikes in the graph. So when I graph it at x equals -2, right here, there should be this spike in the graph where it's going to infinity on one side and negative infinity on the other side. I said there's only one, I only see one, and it looks to be where we said it was. But notice, even if I let you have a calculator on the next quiz test, which we wouldn't, you don't see the hole in this question. Calculators are not programmed very well to show if there is a hole. Like, you can look at this and you have no idea. But from our algebra work, we think there's a hole at 4 5/6. So if you hit trace 4 enter, it will jump to that point. And notice it says when x equals 4, y doesn't exist. That's because there's a hole at that instant. But your calculator is not programmed to draw in the hole there to show that. And since it's hitting the points right before it and all the points right after it, and then it has to estimate which pixels to fill in, it looks like it's hitting all of those points. So simply by doing trace 4 enter, you can jump to that and see that there is a hole there, even though it doesn't look like it. And then the best way to check your y value, this isn't ideal, but if you're there, if you move your cursor a little bit to the left, you can see the y value is about 0.8. Move it a little bit to the right, it's also about 0.8. And I said that the y value was 5/6. And 5/6 as a decimal is around 0.8. So it appears to be in the right y value range, even though it doesn't have a way to show you that. Okay, if I check the second one, and this is what I would want you to do when you do these other ones. Well, I probably shouldn't have done that, but that's okay. Okay, so and I don't know that you need to check every one of these with the graph, but you might trade off, where you check one and then maybe your neighbor checks the next one for both of you, or just share that information. Okay, so question 5, this rational function looks like this. And again, we're going to talk about the rest of the graphing stuff next class, and there's going to be another 4 or 5 rules I'm going to have to throw at you that you have to know the rules. That's why you want to solidify these 3 today. So in question 5, we said this guy should have 2 x-intercepts at -1 and -2. So my calculator It better cross the x-axis 2 times only, and it better be at -1 and -2, so that seems to check out. We also said that there's a vertical asymptote at x equals -5, so that's a little bit harder to see. Here's x equals -5, so it is trying to spike there. It's just that this graph is kind of zoomed in a little bit. So if I zoomed out, I think it would be easier to see. Yeah, so here's x equals -5. One side's going to infinity, one side's going to -infinity, but I did have to zoom out to see that. Zoom 6 puts it back in the way that you're used to seeing it. And I said there's a hole when x equals 0. It was almost hitting the value 2/5, but it's skipping that value. So again, graphing it, your calculator does a poor job of doing holes, but on this one you can actually almost see it if you're really paying attention. There's a little tiny dot missing this time. It's just not consistent. That's why you can't rely on that. So if I hit trace 0 enter, it should tell me that there is no y value when x is 0 because there's a hole there. But you can move the cursor a little bit to the left to see that the y value is around 0.3. A little bit to the right to see the y value is around 0.5. And I'm saying the y value is 2/5. And of course 2/5 is about 0.4. So 0.4 is certainly around 0.48 and 0.32. So it seems like that is correct too. So that's really the best that you can do to check your answers. So find the numbers that make the numerator 0 and the denominator 0. The ones that make both are holes. If it makes only the numerator, it's an x-intercept. If it makes only the denominator, it's a vertical asymptote. So if you would, please practice the other 2, 3, 4, 5 of those questions. And you guys got about 40 minutes to do that. So you should have time to do that and check your answers. But again, the reason why I'm splitting it up this way, instead of trying to give you a ton of this information in one day, do your best to make sure that you really understand and know how to find these 3 from today so that you don't have to worry about these next class and you can focus on the other 4 or 5 you have to know. Okay, and then of course, any of that I can help with, just let me know. And I did add up there that I recommend that you do at least a couple more questions from your semester test review. Doesn't matter which ones, but do at least 5 more so that you have at least 10 finished. I think you should have plenty of time to do that with today. 40 minutes for 5 questions, and then you don't even have homework. So I'm going to finish grading the rest of these quizzes so I can get those put in the grade book. But I think that's it for today.